Okay, so basic integration techniques. This is basically going to take everything that we've done and just mash it up all together. So we need to figure out what type of integration we're dealing with. In fact, it may pull in some trig identities from last year. So we'll have to watch for that as well. All right, so here's the first one. 2x minus 3 over the square root of x squared minus 3x plus 1. So the first thing I usually look at on these is, okay, can I do u substitution? So underneath the radical, I see this. So if u is x squared minus 3x plus 1, then du would be 2x minus 3 dx. All right, so that gives me u here, and this is du. So that's my attack on the integration, is I would use u substitution on that one. All right, so I'll let you finish that. So I'm just going to kind of go through like how to look at them and then figure out what you want to use. So this next one, if I let u be what's underneath the radical, so if I say u is 8x minus x squared, then du would be 8 minus 2x dx. I don't have, I'll put parentheses around this up here also. I don't have this derivative. So I don't think I'm going to be able to use u substitution on this one. All right, but I do know that I have some trig integration that I can do, like sine inverse, cosine inverse. I have those formulas. In fact, the basic integration formulas I've also included with this assignment, so you can kind of look back at those. So in the denominator, underneath the radical, I'm going to try to complete the square. All right, so I'm going to factor out a negative 1, and that would give me a positive x squared minus 8x, and then I'm going to divide the middle term by 2 and square it. So negative 8 divided by 2 would be negative 4, squared would be 16. So I'm going to add 16 and subtract 16 because that's 0, right? And then I have this stuff right here that factors into a perfect square trinomial. All right, so now I have negative 1 times x minus 4 squared minus 16. So I'm going to push the negative 1 back through, and so that makes this a positive 16 minus x minus 4 squared. And that's underneath the radical. And so now I can look at the integration formulas, and arc cosine fits this. So I can let u be x minus 4, and then a is 4. So I can plug into that formula from there. All right, let's look at number 3. Number 3 is kind of crazy because I have cosine x sine 2x and then sine x cosine 2x. So maybe that reminds you of the sine sum formula. So sine A plus B equals sine A cosine B plus cosine A sine B. Maybe you remember that from trig. So that means this is actually the integral of sine of x plus 3x dx, which is the integral, 2x. I've already added those together, my bad. So that's this angle plus this angle. So that means this is sine of x plus 2x is 3x dx. And then I can use substitution on the angle and integrate that. All right, number 4, 1 over sine x. Okay, well, if I let u be the denominator, I don't have the derivative. I don't have the derivative of sine anywhere to get rid of the dx. So I can't do that. It would be nice to have cosine in here. So I think what I'll do is multiply the bottom by 1 plus sine x, because that will give me 1 minus sine x squared. And from trig, I remember that 1 minus sine x squared is cosine squared x. So I think that will help me with u substitution. So now I have the integral of 1 plus sine x over, this is when I distribute this through, I get 1 minus sine squared x. But I know from trig that sine squared x plus cosine squared x is 1. Do you remember that Pythagorean theorem for trig? Cosine squared x equals 1. So if I solve for cosine squared x, I get 1 minus sine squared. So that means that's cosine squared x dx. So now I can go ahead and still can't do u substitution, but I think I can split this up and integrate it. So I'm going to do 1 over cosine squared, which is secant squared, plus sine over cosine squared. Well, we know sine over cosine is tangent, so I'll take that. And then 1 over cosine is secant, so this is tangent x secant x dx. All right, and then I can integrate that from there. I know the integral of secant squared x is tangent x, and the integral of tangent x secant x is secant x, so we can integrate that from there. All right, so sometimes when you, like that one, I thought, oh, maybe u substitution, and then you get in the middle of it, and it's like, no, not u substitution, and that's okay. Like, you may take a path, and it may not work out, and that's fine. All right, let's look at this one. So if I let u be the numerator, then du, like, that's not going to work, because I'm not going to get 1 over, I'm going to get 6x, and it's in the denominator, so I can't do that. Since the numerator is one more than, or since the numerator degree is bigger than the denominator, long division is a possibility since they're both polynomials. So I think that's probably what we're going to have to do. So reminder on long division, I have 3x plus 2, and I'm going to divide that into 3x squared minus 7x. So that will go by x, so 3x squared minus 2x, and then I'm going to subtract, so I change those signs, so that's 5x plus nothing, and then what do I multiply by, make sure I got this, what do I, oh, that's a negative 5, yeah. What do I multiply by 3x to get negative 5x, and so that would be a minus 5 over 3. And when I multiply by that, this is going to give me minus 5x minus 10 over 3. And then I'm going to subtract. So I'll change those signs. So I get 10 over 3 over that. And so that's my remainder, and then I can see if we can integrate that from there. All right, let me pause this just a second. Okay, I found it. All right, I knew there was something. I didn't think I came up with a fraction, so let me back up. I put the wrong sign down, so I'm going to fix this real quick. Sorry, you guys may have caught it. I just didn't catch it until I ended up with a fraction. I was like, wait a minute, I worked that, I didn't get a fraction. Okay, so when I subtract this negative sign goes through the whole thing. So I had x times 3x, which is 3x squared, and x times 2, which is 2x, but I'm subtracting. So the negative is going to go here and make this negative, and also make this negative. So I end up with negative 9x. There we go. So now I'm going to say I'm going to multiply by negative 3, and that will give me negative 9x minus 6. And I brought down a 0. There wasn't anything there. And then I'll change the signs because I'm subtracting again. So I'll change the signs and make this a positive. So I get remainder of 6. So it's plus 6 over 3x plus 2. And then I can integrate that. So I can integrate x, I can integrate the minus 3, and I can integrate the remainder. All right, so here's what that looks like if that. So I have the integral now. Move this up just a little bit. I have the integral now of x minus 3 plus 6 over 3x plus 2 dx. So remember, we can split these. So I have the integral of x dx plus the integral of negative 3 dx. You can move the negative out in the front. I could also go ahead and move the 3 out in front. Plus the integral of 6 over 3x plus 2, which looks like it's going to be natural log, right? Because the x is in the bottom, use substitution, the x. So I can integrate each of those individually. All right, so you can see what I was saying, like this is a mashup of everything we've done. All right, and then this last one, We can separate fractions. So right now, if I let u be the denominator, then we might be able to get the numerator part of it, but I don't think we can get all of it. So if u is 1 minus x squared, then du is going to be negative 2x, and I have that plus 2 up there. So I want to separate them so that I can actually use that for 1, and I'll show you what I mean. So when I integrate this, or when I separate it, I have 3x over the square root of 1 minus x squared plus the integral of 2 over the square root of 1 minus x squared. So it's backwards of adding fractions. We're just going to split them up. So if I add these back together, I have a common denominator, and I would have 3x plus 2 in the numerator. But in this case now, I can do u substitution with this one. I can also do u substitution with this one as well. So takes a little bit of manipulation on that one, but you can definitely do it. All right, so actually this one's going to be a trig formula. This one will be arcsine. It's very similar to this one where we completed the square. So u substitution for this one. Oops. And then look at the trig formulas for this one for arcsine, because that's a square root of a squared minus b squared, or minus u squared. So we're good on that one, I believe. All right, so we'll try some of those, and you can let me know what you think. Again, this is about recognizing what you have and trying the integration. So this is challenging. I'm not going to say that it's not, because it pulls everything together. But if you choose the wrong thing at first, it's not going to work. So we can try other things. All right. See you guys soon.